अस्सलाम वालेकुम डियर स्टूडेंट्स। तो आज आपको पता होगा कि हमने ऑलरेडी डिस्कस किए थे मैक्सवेल इक्वेशंस, हाउ वी कैन combine or how we can club these two equations and write it in some compact form, and that was uh, equal to that partial mu f mu nu, that's equal to mu 0 g. So we have seen that, right? So that means, so this is our electromagnetic field tensor. So you are familiar with this, right? And it contains those electric as well as this magnetic field components which are embedded within this matrix. You can say that. And this is the first this Maxwell and fourth Maxwell equation. तो हमने क्या किया था? हमने combine लिखा था instead of this Maxwell equation first and this fourth, इनको हमने combine किया था and we wrote it in this form. So this is our called covariant form. Covariant form of Maxwell. तो इसको हम covariant form of Maxwell equation कहते हैं, right? So why we write it in this form? So this is very important because uh, when we are talking about this is mu and nu. So this we are working in the four-dimensional space. So our space is Minkowski space, four-dimensional space, and we need to see. So because this is the basic law of this special theory of relativity. अगर हम कोई भी इक्वेशन लेंगे फिजिक्स में, if any physical equation, you take any equation, that should remain invariant if you make transformation from one frame to another frame. So that means if you have two frames, right? So you can, if you want to calculate some E or B in this frame, so whatever the values they have this in this frame, suppose this x, y, z, and this x prime, y prime, and z. So this should be same. So the value of A and B should remain same because you take that Lorentz force, you take that F, that's that Lorentz force. If you write for this one frame, so you should measure the same value of this F in the another frame. Then we can say that all physical laws remain invariant under the transformation from one inertial frame to another inertial frame, right? So this is clear. तो इसीलिए हम क्या करते हैं, फॉर एग्जाम्पल अगर हम एक फ्रेम में जाएंगे, वी आर टॉक अबाउट द दीज आर इनर्शियल फ्रेम्स, राइट? तो अगर हम क्या करेंगे, अगर हम इलेक्ट्रिक फील्ड कैलकुलेट करेंगे एक इनर्शियल फर्स्ट इनर्शियल फ्रेम में, so it is not necessary that it should have same value in the another frame. So this is very important, right? So in order to get the same value of this E and B, so that they should remain invariant under the transformation, so we are defining in terms of that this electromagnetic field tensor, right? तो हम इसको इसमें फॉर्म में लिखते हैं, so that because we can write that F mu nu when you make transformation of this F mu nu, this electromagnetic field tensor from this frame to this frame, so you will get the same value. They have same value, right? So that means so we can combine these two equations. We have combined this Maxwell equation first and fourth. That is this Gauss law of electrostatics, and we modified form of this Ampere's law, right? Now I can do one thing now. Okay. Now let's write now the our third Maxwell equation. Second Maxwell equation, you can write that. We can write that equation as that lambda dot b equal to 0. That lambda dot b equal to 0, and that lambda cross b is equal to minus partial b by partial, right? So this is a well-known equation in this well-known Maxwell equation, which states that magnetic monopoles doesn't exist, or you don't have magnetic charges. Right? If you have this magnetic lines of force, they form closed loops. So we don't know whether where from it will starts and where they end. So they form a closed loop. So that's why the divergence of that magnetic field equal to zero. And this is another this Maxwell equation, fourth Maxwell equation, third Maxwell equation. So uh, which states that this electric field can be produced, or you can write the rotation of this electric field will be rate of change of that magnetic field with respect to that time, right? So this is Maxwell equation number second and fourth, right? Now let us write now. So let us write these. We can combine these two equations. We can write in दो equations के बदले I can write them in some compact form, right? Okay, so we can rewrite this as, so if I write this equation, so this equation, so lambda dot b I can write as, so this I can write as that partial one b1, or you can partial one b1 plus partial 3. Okay, or you can rewrite this as partial 1 b1 plus partial 2 partial 3. Okay, so we know that we have this f mu nu, it is known to us that f mu nu, that's equal to that 0 minus e1 e2. Okay, this is e1 e2. Okay, I think it's correct. So let's write now. So we can write this as, because this is partial b1. So b1 के बदले में क्या लिखूंगा? So instead of b1, or you can write this as, instead of this b1. So b1 is basically, you are taking, these are basically first 0, 1, 2 and 3, right? And this is 0, 1, 2 and 3. So this is which component? That is b1. b1 is our this component. So this will be f32. So this will be f32. And similarly, our b2 will be equal to, so that is equal to, so b2 will be equal to, that is this term. So that is f13. F1, and b3 will be equal to, so what, so b3 क्या होगा यहाँ पे? So b3 will be, that will be f21. Yeah. Okay. So instead of this term, I can write this as, so our nebula dot b will be equal to, so that will be equal to, you can write that partial one instead of, तो b1 के बदले में लिखूंगा f32 plus, and that is equal to 0, right? Okay, so let us write now this nebula dot b. So this is our partial one f32 plus partial 2 f13 plus partial 3 that's equal to 0, right? और इसको मैं ऐसे भी लिख सकता हूँ because I can put this in cyclic order because we have that this is 1, 2 and 3, so I can put it in some cyclic order, right? So instead of this, because we know that this F mu nu, this electromagnetic field tensor, we can write this as minus times F mu nu because this is antisymmetric, okay? Because we can write this F mu nu as F mu nu is, you can rewrite this as partial mu A nu minus partial mu A, right? Now if you change the indices, अगर मैं nu को mu से replace करूंगा तो यहाँ पे नेगेटिव साइन आएगी, इसलिए मैंने यहाँ पे लिखा F mu nu should be equal to minus F mu, so that means this is antisymmetric tensor. Antisymmetric, okay? So I can write now, so instead of this term, I can write as, okay, so let me write this as, this term will be equal to, so it will be partial 1, so this will be F23 minus times plus uh, partial 2 F31 plus partial 3 F1. So that will be equal to 0. Or you can add that partial 1 F23 plus partial 2 F. So this is sorry, I did a mistake here. So you put here, okay. So I can write here this is F31, sorry, plus F31 plus, that's equal to 0, right? Or you can do one thing now. Rest of this term, तो इस term के बदले में क्या लिखूंगा? So I can now I can write now. I can write this rest of this. I can write this as 1 should be your mu, and 2 should be mu, and 3 should be lambda. तो इन 1 के बदले में mu लिखूंगा, 2 के बदले mu and 3 के बदले lambda, right? So this term will be, we can add that this will be partial mu plus partial mu, or you can put, because so you will get confused here. So let me write the same notation. Okay. So we can write this as that's equal to partial 1